Blake, he has so much to teach us about our own experience of technology and how that prescribes a certain experience of the world, in particular, a disenchanting kind of mechanistic prescription, mechanistic reproduction of reality that forecloses creativity and community, communication, creative interaction with each other and with the environment. So that's a big part of what's at stake in the opposition between innocence and experience. What I'm referring to here, drawing on Alison Gopnik, the psychologist who I'm going to be talking about in a minute, a separate kind of intelligence, the childlike, innocent intelligence oriented towards curiosity, exploration, as opposed to this orientation toward what's called confirmation bias characterizes the adult perspective on the world. We are always more oriented towards noticing what confirms what we already know. This is a psychological fact about adults. Versus children who have a more experimental, exploratory, almost bias towards what falsifies what they know. They're curious about what is surprising. And that what Alison Gopnik is going to emphasize is that that's more like science. Science is based on the principle defined by the philosopher Karl Popper of falsification. It's only valid if it's falsifiable. So the basic principle of scientific method is always looking for falsification. So again, there's something really crucial that Blake's getting at, and in his juxtaposition of innocence and experience, and always wanting to explore that tension. It's a real important tension that we're still too quick to ignore. And so we have a lot to learn from that thematic focus in Blake, but I also want to talk about how he uses his form, the form of his art, to draw us into this practical, experimental, exploratory perspective on the world. So I love this image of like I'm holding this other like avatar to guide me. This alternate intelligence. The adult is being led by the child. This is an introductory plate to the Songs of Innocence. And here's the illustration for the introduction, the song that I'll examine later. And what's characteristic, I'll get more into Blake's process, the process of his art, but just notice, again, as I was talking about in Thel, holistic patterning in his imagery. Blake was trained as a drawer from a very young age. He's a great skill at depicting human anatomy. Piecing together of the human form blends into this modular patterning in the whole environment. So lovely to look at his images and see how sort of branches are, hard to distinguish, become intertwined with clouds, with the human figure itself, the background, what seems like maybe hills in the background turn out to be animals, the repetition of forms in the human figure and in the plants, the environment, the scene, the background becomes hard to distinguish from the figure in the foreground. So I'm going to show you 10 minutes of a lecture by Alison Gopnik You can see the whole lecture. You can find the whole lecture here. And in this, she discusses this idea of a separate intelligence of children, that drawing on the principle of what she calls life history, the importance of life history in biology. That's to say that organisms have a developmental trajectory, a stage of childhood and a stage of adulthood, and that this is important to the development of intelligence. That intelligence isn't just a unified thing of understanding. The extent of this period of incapacity, inefficiency, and dependence, not being able to negotiate the environment and fend for yourself, feed yourself, but a period of exploration, of exploring the environment, of experimentation, learning about the world. This period of childhood gives way eventually to sort of fixed ways of negotiating the world and a narrowing down to a certain set of knowledge that then in the adult stage of life we focus on exploiting. So in the beginning of this, she talks a little bit about Alan Turing, who is credited with inventing the computer, and the idea of artificial intelligence. And Turing wrote about definition of artificial intelligence in terms of what he called the imitation game. And this is very interesting, especially for people in the humanities. We usually think of artificial intelligence as if intelligence were merely a kind of computational power, but defined intelligence differently. Defined it functionally in terms of mutual recognition. That's what he means by the imitation game. And that goes back to what I was talking about, as referring to Hegel's master-slave dialectic and the pursuit of subjective identity as a creative cultural project. Turing suggests the same thing about intelligence. Artificial intelligence, there's no objective definition. There's only a functional definition. That is, the imitation game would be a questionnaire where you're asking the computer questions, and you would be able to convince a human questioner that he or she was interacting with another person. So you might think, oh, it's just about testing computational capacity to seem intelligent as a person. But in fact, Turing thought of this idea, first of all, as a way of recognizing gender. Again, a culturally constructed category. And in this little lecture by Alison Gopnik, she says the imitation game, that the Turing test would be best applied to recognizing children, the childlike intelligence. So a true artificial intelligence would be one that could emulate the intelligence of children, the exploratory, more playful, experimental thinking style of children. So check this out. She's really brilliant, can explain it a lot better than me.
So everyone knows that Turing talked about the imitation game as being a way of trying to figure out about whether or not a system is actually intelligent or not. But what people often don't appreciate is that in the very same paper, about 3 paragraphs after the part that everybody quotes, he said, wait a minute, maybe this is completely the wrong track. And in fact, what he said was, instead of trying to produce a program to simulate the adult mind, why not rather try to produce one which simulates the child? And then he gives a bunch of examples of how that could actually be done. So for several years I've been saying, listen, here's this quote. Everybody stops reading after the first section. They never actually get to the second section. But when I was actually searching at lunch to make sure that I got the quote right, I discovered that there are now about, when you Google this, you now come up with a whole bunch of examples of people saying, wait a minute, this is actually the thing that you should be quoting from Turing, and nobody ever quotes it except me, 2014 in the last year or so. And I think there's actually a reason for that, which is that the explosion of machine learning as a basis for the new AI has made people appreciate more generally the fact that if you're interested in systems that are actually going to learn about the external world, the system that we know of that does that better than anything else that we know of in the universe is a human child. So a human child would be a good place to look. Now, one of the consequences of that I think is not so obvious is that actually thinking about children not just as this is an immature form of the thing that learns that ends up being an adult intelligence, but actually thinking about children as being a separate kind of intelligence, which is sort of implicit in the Turing quote, that actually turns out to be an idea that fits with a lot of really interesting ideas in evolutionary biology to talk about the an interdisciplinary relationship. So in evolutionary biology, there's increasing work on the idea of life history. And I'm sort of amazed, if you talk to developmental psychologists, for instance, like me, they've never even heard the word life history. Life history is the idea about the developmental trajectory of a species, how long a childhood it has, how long it lives, how much parental investment there is, how many young it actually produces. And it turns out that general feature of what its life history is like is often much more explanatory of other features of the organism than things that might seem to be more apparent. And in particular, a relationship that comes up again and again and again is a relationship between what we perhaps anthropomorphically think of as intelligence, things like being able to deal with many different kinds of environments, learn about them, and adapt to them effectively. That turns out to be very, very consistently related with a particular life history pattern, namely a life history where there's few young, there's a very long period of immaturity and dependence, and there's a great deal of parental investment. So the strategy of producing just a few younger organisms, giving them a long period where they're really, really incompetent, where they're incapable of taking care of themselves, and then having a lot of resources dedicated to caregiving, to keeping them alive, that turns out to be a strategy that over and over again is associated with higher levels of intelligence. And that's not just true for primates. You can see this in analyses of hundreds and hundreds of primates. It's true for marsupials. It's true for birds. It's true for cetaceans. It turns out that it's even true for insects. So if you look at different subcategories of butterflies, for example, that depend more or less on learning, what you see is that they have a different developmental trajectory such that the ones that depend on learning have a longer period of immaturity and produce fewer offspring. It turns out to even be true for plants, to get back to some of the things that we were talking about. We were talking about Caroline. It turns out to be true for immune systems. So creatures that have more complex immune systems also have this longer developmental trajectory. So it looks as if there's this very, very general principle, this very general relationship between the very fact of childhood and the fact of intelligence. And that might be very informative if one of the things that we're trying to do is create artificial intelligences or understand artificial intelligences. You can even see this in neuroscience. So what you see very characteristically is this pattern of development where you have an early period of synaptogenesis, lots and lots of proliferation, lots of plasticity, and then there's a real tipping point. It isn't just a continuous process of development. You have an early period where you have lots and lots of plasticity and synaptogenesis, and then you have this tipping point where the kinds of neural connections that have been made become strengthened, become efficient, become myelinated. You get very clear segregated networks, and then you have this point where what happens is that you start out with this very plastic system with lots of local connection, and then you have a tipping point where that turns into a system that has many fewer connections but much stronger, more long-distance connections. So you start out with a system that's very plastic but not very efficient, and that turns into a system that's very efficient and not very plastic and not very flexible. And what all this suggests is that, and it's interesting that isn't an architecture that's actually typically been used in AI. but it's an architecture that biology seems to use over and over again to implement an intelligent system. So one of the questions you could ask is, how come? So why would you see this relationship? Why would you see this kind of characteristic neural architecture, especially for highly intelligent species? And of course, we're way out on the end of the distribution. So where our chimpanzee young are producing as much food as they're consuming by the time they're 7, we aren't doing that even in forager cultures until we're 15, until well after adolescence. And we have much larger brains. We have much greater capacities for intelligence. And what I've proposed is that it may be that a good way of thinking about this strategy is that it's a way of resolving the kind of explore-exploit trade-offs that you see all the time in AI. So one of the problems that you have characteristically in AI is that as you get a greater range of solutions you can have, as the space of solutions gets to be bigger and bigger, that seems to be moving in the direction of a system that's more intelligent, a system that can do more different things, that can understand the world in more different ways. When you do that, what you also have is a big expansion of the search problem. So if there's many more different things that you can do, how can you search through that space more effectively? And one way to solve that problem that comes out of computer science is start out with a very wide-ranging exploration of the space, including parts that might turn out to be really unprofitable, and then gradually narrow in on solutions that are actually going to be more effective. So my slogan is that you could think about childhood as evolution's way of doing simulated annealing. So it's evolution's way of starting out with a very high temperature, very general, very broad search, and then narrowing it. And of course, the problem with the high temperature search, this gets to problems about scientific interdisciplinarity too, is that you could be spending a lot of time considering solutions that aren't very effective. And if you're considering solutions that aren't very effective, you aren't going to be very good at actually effectively going out and acting in the world and performing the 4Fs and doing all the other things that we need to do as adults. And some of the interesting consequences of this picture of what intelligence is like is that many things that seem to be bugs in childhood, for instance, actually turn out to be features. So both literally and metaphorically, one of the things about children is that they're really noisy. They produce a lot of random variability. When I'm trying to explain the annealing idea to a general audience, I'll say, look, here's 2 ways of thinking about the system. Here's a big box full of solutions, and you could be wildly bouncing around this box, going from point to point and bouncing off the walls, or you could just be staying in one place and carefully exploring the space. Which one of those sounds like your 4-year-old? That kind of randomness, variability, noise, things that we often think of as being bugs actually could be features from the perspective of this exploratory space. Things like executive function or frontal control, which we typically think of as being a feature of adult intelligence, our ability to do things like inhibit, to do long-term planning, to keep our impulses down, to have attentional focus, which we tend to think of as being features, and are features from the exploit perspective, could be bugs from the perspective of just trying to get as much information as you possibly can about the world around you. So being impulsive, acting on the world a lot, those are good ways of actually getting more data. They're not very good ways of actually planning effectively on the world around you. And I think this gives you a really different picture about the kinds of things you should be looking for in intelligence. And it means that some of the things that have really been difficult for AI to do, like creativity, broadly speaking, being able to get to the right kind of new solutions, to get to solutions that are genuinely new and genuinely aren't just crazy. That is a capacity that human children that's something that human children are remarkably good at. In our empirical evidence, often better at it than human adults are. It's something that AIs have actually had a really hard time implementing. So you can have a lot of random search, or you can solve a problem that's very highly constrained, but the combination of being able to solve problems that are highly constrained and search for solutions that are further away, that's been the thing that I think has been the most challenging problem for AI to solve. And that's a problem that children characteristically solve, and solve more effectively and put more time and energy into than adults. I think there are some other consequences for thinking about this particular life history as a solution to intelligence. So, for example, one of the things that we know children do is get into everything. One of the things that we know that adult scientists do is do experiments. And that kind of active learning where you're actually determining what your data sample is going to be, and you're actually literally and metaphorically expending energy on getting the right kind of data sample, not just the right kind of data sample that will be useful, but exactly the kind of data that will cause you to change the current view that you have of the world. That's actually a very unusual thing to be able to do. The idea that you would go out into the world and spend calories and energy in order to turn out to be wrong. That's something that children very characteristically do, and that if Danny were here, he could tell you adults very characteristically don't do. And another aspect of what children are doing that I think would be informative for thinking about intelligence in general is that children are cultural learners. So one of the effects of this life history for human beings in particular is that it gives us this capacity for cultural ratcheting. It gives us a way of balancing innovation and imitation. So if all we did as a result of cultural learning was imitate exactly the things that the previous generation had done, there would be no point in having cultural learning. And there's a constant tension between how much are you actually going to be able to build on the things that the previous generation has done, and how much are you actually going to be producing something that's new enough so it would be worth having the next generation imitate. And I think having this developmental trajectory where you start out with a broad exploration and then narrow in on actually exploiting particular solutions gives you a kind of a way of solving that problem in the context of cultural evolution. So it gives you a way. Now, there are other ways that you can do that even as an adult, like have an interdisciplinary problem or give adults things to do that are new. One of the ones that I've been interested in looking at recently is actually psychedelic chemicals seem to have the effect, rather surprisingly and in great detail, of putting adult brains back into a state of plasticity that looks much more like childhood brains. So the effect of psychedelic drugs neurally is that it increases the local connections, it breaks the long distance network connections, it literally induces plasticity and induces more synaptogenesis. It's interesting because these chemicals that have very different other properties, but that are sort of have the effect of having psychedelic effects on phenomenology, LSD and MDMA. So the ones that have been studied the most actually is psilocybin, because LSD has a more moral panicky kind of reaction. But psilocybin, LSD, NMDA, and ketamine are all examples of very different chemicals that all have the same phenomenological properties, and they all turn out to have the same kind of this neural effect of driving the system back to something that looks more like childhood plasticity. And that may actually be a really interesting way of testing some of those ideas, and that would be a good explanation for what otherwise seems very puzzling, which is that a small chemical change, at least by report, can lead people to have very large changes in the ways that they see the universe, or large changes in the ways that they behave. So one of my slogans is that you could think about psychedelics as doing for the individual what childhood does for the culture. So what childhood does for the culture is it takes a system that's relatively rigid and it injects a bunch of noise and variability into the system, shakes it up, shakes it out of its local optima, and then lets it settle into something new. And thinking about learning in terms of active learning, so thinking about actually having computers that would go out and play and explore and get into things the way that young children are playing and exploring and getting into things, that is a sense in which children might be a model for intelligence that's different from the models of intelligence that we currently have. Thinking about systems that are learning from previous generations, that could be a model for intelligence that's different from the models of intelligence that we currently have. And finally, I think thinking in this kind of life history perspective, that the thing that's distinctive about human intelligence is having a life history with a long childhood and a lot of caregiving, is that our conceptions of moral relations, I think, change too when you think about it that way. So our model for naturalizing morality has very much been a model, thanks to people like Robert, of contracts. It's been a model of having individual people who are more or less equal in their status and in their relation, who are trying to develop a contract that will lead to the best outcomes for both of them. And if you think about both markets and democracy, those are essentially wonderful institutions and inventions that we had for maximizing that process of contract making, so that we don't actually have to have face-to-face contracts to maximize our preferences. We can do it using institutions like markets or democracies. But if you think about caregiving relations, and if this picture is right, caregiving relations are absolutely key to having this life history. If you think about the relation that actually means that every parent, no matter how bizarre or weird or crazy their child is committed to taking care of that child, that's a very, very different kind of relation than the contractual relation. It's asymmetric, right? So maybe your kids are going to take care of you when you're an adult, but that doesn't really, when you're old, but it's not clear that they will, and that doesn't seem to be the motivation behind the life history. It's something about protecting next generation that can introduce variability into the system. So they have this kind of fundamental asymmetry, and they have this kind of fundamental transparency about them too, so that when you're attached to a baby, for example, it doesn't really matter very much. You don't know very much about what the properties of the baby are. You don't know whether that baby is going to turn out to be valuable or not. There's just this kind of transparent attachment that you have. And again, it's having that transparent attachment that lets you have the noise and variability and mess, right? So if you only were attached, and this is a bit of the modern middle-class American model, right? If you only were attached to your children because you thought they were going to come out really well, you thought that you were attached to children because you wanted the children to come out as well as they possibly could, the sensible thing to do would be to go look out at the universe of children and find the ones that you thought were most likely to succeed, and then have everybody put all their love and attention into those, and then let the other ones perish, right? Now that seems like a crazy system. But part of the reason why it's a crazy system is because if you think children are this source of unpredictable variability all the time, then what the kind of moral commitment that you need to be able to allow unpredictable variability to thrive is by not anticipating what the outcome of caring for that child or caring for that person is going to be.
So just to review a number of really important things that she pointed out. Innocence versus experience, childhood versus adulthood, two different models of intelligence. Plasticity versus efficiency. So again, experiment, exploration, curiosity, the plasticity of children searches out surprises for the sake of adaptability, change, versus the efficiency of the rather hardwired, dedicated strategies of adult intelligence. That David Bowie song, Changes, the children that you spit on are not afraid of change. That's the intelligence that is unique to children and that is integral to human intelligence. Although childhood requires this period of immaturity, of dependence, it's for the sake of cultivating this separate kind of intelligence. It's not merely dependence. It's not merely a lack of adult intelligence. So some examples to think about to illustrate this. Play as environmental learning. Environmental learning, it means interactive, testing the environment. And I want to suggest, I think I've mentioned it before, that this interest in binaries Blake's interest in binaries, conceptual binaries, but also his aesthetic style, integrating his text with his painting, his visual representation, and the organic forms that characterize Blake's painting style. Sort of a universal form in nature. It's related to fractals, which I've mentioned before. That's to say that these binary forms, like in the form of blood vessels, capillaries, neural networks, the physiological organization of animals, plants, leaves, organic forms in general are built in this arborizing, these bifurcating forms to test and interact with the environment. Bifurcations are ways of responding to the environment and growing in response to environmental feedback. We see these forms throughout nature. A river delta, lightning has this pattern, frost has this pattern. It's just sort of a universal shape in nature, and it relates also to what Alison Gopnik, I think, was suggesting in terms of psychedelics, and the complexity, and which has, was rooted in mathematics. Geometrical shapes exhibit a kind of roughness or complexity, the more detailed the scale of representation. And so this is to say that these forms are that we associate like with psychedelic aesthetics, or that I'm associating with Blake's writing style, are images of the dissolution of subject and object, which is an experience associated with psychedelic experience, losing your sense of yourself, dissolving into the environment. And I think I've heard that the way that a person's brain looks on a functional magnetic resonance imagery when they're on psychedelics is kind of like the way a child's brain looks. I think that's what Alison Gopnik was trying to suggest, that a similar kind of plastic interactivity characterizes both mental experiences. So she also talked about annealing as a way of describing the way in which certain channels get reinforced, annealed, like solidified, rigidified, and more efficient, more effective, more able to be exploited in a self-sufficient, mature adult. In terms of that dissolution of the subject-object, what's interesting about play, another thing that Alison Gopnik emphasizes in this book, The Gardener and the Carpenter, about these two different learning styles, the organic, interactive style required for gardening, and the prescriptive instrumentality of carpentry. Gopnik refers to a scene in Great Expectations by Charles Dickens when Miss Havisham ironically tells Pip, the main character, she says, play for me. I want you to play. And what's ironic about it is you can't tell somebody to play. Play can't be prescribed or instrumentalized. It's by definition a spontaneous, organic, kind of interactive state. And I think there are other experiences that are characteristic of that, like sleep. You can't intend to sleep. You kind of need to let go of your executive function of being in control and instrumentally willing yourself. Sexuality, music, reaction to music is an organic, kind of spontaneous losing control, letting the music kind of flow through you. I think art has that same experience. So these are all ways in which we can recognize the characteristic attitude of play and intelligence and agency, interactive agency of play these certain limited ways that persist in adult experience. They're very important to our experience of poetry, really key aspects of romanticism, interest in nature, children, music, and we'll get into this more, especially when we get to Frankenstein, but alternative forms of social reproduction. I've mentioned already the idea of friendship. This is like thinking critically and creatively about human reproduction. So reproduction of the species, but also the experience of pleasure. And there's an erotic dimension to it that's very significant. Another thing that she mentioned that is key, I think, to the interplay of innocence and experience in Blake is generation gaps, which she mentioned the term cultural ratcheting, which is that the interplay between children and adults is important for the learning, the development of the species on a broader time scale, not just of individuals, but of families and societies over time, can learn faster what it took adults. It took their parents a while to learn what they know, for their knowledge to get annealed and rigidly established. But children, with their plasticity, absorb it much more quickly. If you think about the way children absorb language, adults have to learn it slowly in this painstaking way. Children absorb it almost spontaneously. So this has a ratcheting effect. It leverages learning over time. So things come naturally and spontaneously to children that it takes adults more time to learn. So that generation gap is really important for it's an adaptive strategy. That's part of what makes humans in particular successful, that because our intelligence is such an important part of our adaptation. And so hence the danger, the morbidity, of the segregation of children and adults. That's really key point that Blake is pointing out, and like David Bowie too, these children that you spit on by disparaging, dismissing the separate kind of intelligence specific to children. This effect of cultural ratcheting suffers to the extent that we adults only recognize adult intelligence as mattering. The interactivity of experience and innocence, what Blake is really trying to emphasize is the interdependence of the two. It really strikes me as when I think about it, when I was a kid, it seemed like all I saw was kids all the time. And now that I'm an adult, it seems like all I see is adults all the time. There's a weird segregation of children and adults. It's also interesting to think about this in terms of education, how much of education is just kind of like training and how to be an adult rather than really cultivating the intelligence of children. So a key ambition of Blake's work is to reactivate a kind of childlike learning and intelligence, and that's integral to his work on all levels, thematically, but also formally in the formal stylization of his work. So I want to emphasize, as much as Blake is critical of mechanism, of the way in which the modern world has become predictable, calculable, is so deadening to Blake. That turned into a machine, this sort of self-reproducing world of adult rationality and objectivity is so deadening of creativity, and that spontaneous, playful, pleasurable, creative being in the moment and interactive. We were closed off and just sort of with our heads down, cranking through these repetitive mechanical processes. The tremendous irony of this, though, is how mechanical Blake's own work is. I've already talked about how, you know, the sort of modular style of his painting. It has a kind of mechanical piece together aspect to in his art. But what I want to suggest is that he's actually evoking this kind of fractal, psychedelic, interactive form. Uh, as a enchanted mechanics. He's trying to draw us into a kind of divine mechanics of nature itself, as opposed to the deadened mechanics of mere machines. So this amazing picture of Isaac Newton, he depicts the reduction of this, you know, psychedelic complexity. This is so evocative of those psychedelic fractals I was just looking at, of nature itself. Newtonian science reduces it to these stark lines, stark causality, disenchants the world. Blake anticipates the sociologist Max Weber's analysis of modern disenchantment. Max Weber came up with the idea of the Protestant work ethic and the spirit of capitalism, and talked about how the modern world becomes disenchanted, like this just rat race of, you know, being on the treadmill, work, without any sense of actual purpose, actual, you know, inspired reason for working. This is what Blake wants to restore, and what I really want to emphasize is that he's relying on mechanics. He's not just escaping into nature. His work is engages with mechanism in an incredibly creative way, as I've already mentioned. His innovative printing technique. But more than that, his critique of science, of Newtonian science, anticipates 20th century more complex relativity that came to define 20th century science, with quantum mechanics and the kind of fractal forms that emphasize interactivity, the idea of quantum mechanics, that to observe, there's no view from nowhere from which you can observe nature objectively, that observation is always already a kind of interaction and involvement in these complex fractal patterns of interaction. So I just want to play you a short interview with a biologist talking about Blake's view of science.
Showing there is a fallen angel trapped in the cave of his perceptions. Do you see anything else in it, or what do you see?
Well, I think the idea of a fallen angel is a very good one, because angels are beings of light before they fall, and there's something still divine in the form of Newton. But what he's doing is drawing these abstractions, these lines on paper, a two-dimensional geometrical model in a world full of colour and quality and movement and form. And in that sense, I think Blake pictures it very well. I mean, there is something noble about Newton and inspiring. That the whole of the 18th century rationalist movement, the so-called Enlightenment, was based on this idea of Newtonian reason as the ultimate. But what's wrong with it is that it's a limited form of reason, a limited vision of things. And in this picture, you can see there's so much else in the world. And interestingly enough, what Newton left out in his abstract geometries is something that modern science is now beginning to bring back in through chaos and fractals. The new kind of mathematical imagery we have has left Newtonian abstractions far behind, even within orthodox science.
And you're not surprised that someone like Blake would have reacted against this ferociously, calling it the tree of death and so forth. I mean, it must have struck a sort of nightmare chord within him.
It would indeed have been a nightmare. There was no spirit, there was no soul. Nature was dead and inanimate. There were no angels or consciousnesses in the universe. Animals and plants were machines. And I think it's had a huge impact on our civilization. It's split the sciences from the arts. It's split science from religion. It's fragmented our whole culture.
And I suppose Blake, in a sense, was remarkably prescient, wasn't he, in his attacks upon Newtonian science. For example, he denied causation. He said every natural effect has a spiritual cause, and he talked about when the organs of perception change, objects seem to change. That seems to strike a very modern chord, doesn't it?
In modern science, there's been a recognition of the obvious in quantum physics, that all observations depend on observers. And so the human mind has come back albeit in a very stripped down and not very interesting form, but it's had to be admitted at last by scientists that our observations depend on us. Our theories are products of our own minds.
His central perception was that the imagination is human existence itself, that it looks into eternity from all its angles. Is that something you would agree with him about?
Well, I think the imagination has to be seen of as much larger than our merely limited human minds. And since Blake believed in angels and God, there's a whole realm of consciousness, of imagination, that goes far beyond the human realm. If I understand Blake correctly, he was talking about a living world, a world permeated by consciousness and spirit, full of life and quality. I think the science of the next millennium, say, will be much closer to the kind of view.
So, as we've seen, so much of Blake is about exposing this deadening ideology, nursing unacted desires. And in London, Mind-Forged Manacles is, Blake's key definition of ideology. A lot can be said about the word choice in this poem. The chartered streets, the chartered Thames. So it's like Newton with the charts, like the organic flow of the river, just exactly what I was talking about before, those arborized tributaries is reduced to a chart. Every ban, the voice is banned, like banished, like he was saying his joys and desires are contained in the garden of love, ostracized, the cries appall the church, and blast. All these images of mechanical power, recall the tiger, all the, the anvil and the chain and the furnace and the hammer, and make the world topsy-turvy. So what the marriage, the institution of love and sexual reproduction, the family becomes an institution of death, of disease. Sex becomes disease. We'll talk about that in terms of the sick rose. Blake evokes this inversion of love of the cultural values, turning love into death, and the great stanza here at the beginning of the poem, The Smile. There's a smile of love, and there's a smile of deceit. And there is a smile of smiles in which these two smiles meet. So that is lovely, and how he's saying that there's the smile of love, the smile you expect, or the innocently, naively perceive, earnest smile. And then there's the smile of deceit, what's hidden, what's introduced by civilization, the corrosive, the infernal reversal, the marriage hearse. But then there's also the smile of smiles in which these two smiles meet. There's the abstract, Newtonian concept of the smile per se, the objective smile that doesn't notice these differences. They're the same. It's a smile. It's dead in that disregard of the human dimension that really gives the smile whatever actual effective significance that it has in human life, whether it's deceit or love. This anticipates observation that the 20th century philosopher Ludwig Wittgenstein made about these sorts of terms like anger, grief, joy, emotions, concepts of emotions. We think that they have objective meanings. We think that there's an objective meaning to each of these terms and all the others that we use to describe emotions. But what Wittgenstein points out is that these are functionally defined. And at a certain point, we can't really say what anger is without just pointing to an angry person. That's what it is. Again, that idea, that functional definition, the self is what the self does. You can't define human meanings in abstraction from the medium of actual human existence. Again, that sort of organic metaphor. Our meanings only matter in the context of actual human situations, interactions. So that's a really good way of thinking about what's going on in Blake's Prince. He's trying to point at things that can't be entirely analytically, conceptually spelled out, reductively defined. He's trying to illuminate, again, open the doors of perceptions. These are illuminated texts, trying to show what he says at the beginning of, or on the title of the title page of Songs of Innocence, showing the contrary states of the soul. So giving us a new organ of perception, to again, that interactive, he's showing and he's giving us new eyes to see.